I want to give you a little bit of a lowdown on data. And in particular, I'm looking to answer three fundamental questions. The first is, how does data fit into the CS Principles framework, and in particular, the other big ideas? Secondly, I want to consider, what do we want our students to know? What exiting competencies do we want them to have? And finally, I want to start talking about what sorts of activities might help us give our students those exiting competencies. I did some accompanying PowerPoint slides, and one of the first slides in that set is a little diagram of the big ideas in the Principles course. Keep in mind that while we separate these ideas so that we can focus on them, there is every recognition in the curriculum that these ideas actually are threaded together, that they are woven, very tightly coupled. So let's kind of walk that wheel of the big ideas and make sure we understand how data fits into everything. Data is already off the porch, running with the big dogs, because it is one, has legitimate status as one of the big 7 ideas, but it is couplable to the other ideas in the framework. For example, data is created through the process of abstraction, which is one of the other big ideas. The abstraction process, this idea of constructing data, is very creative. It takes imagination. It is not some sterile, cold activity. So that creativity can be seen at the atomic level of a single piece of data, or even in more complicated creation pieces of data, such as schemas or models or simulations. We use algorithms to manipulate data in a sort of automated kind of way. So you could think of programming as all the software engineering activities that let us manipulate data in the form of algorithmic abstraction. So notice we've knocked off another one of the big ideas in that wheel. When we think about communicating or transmitting data, all of that work activity has led to, among other things, that interesting phenomenon called the internet, another one of the big ideas. And if you listen to a newscast today, you will invariably hear something about data, big data, database security, etc. So it is very obvious that data has tremendous global impact, always in the news for both hazards and hope. So I hope you can understand then that data is very legitimately threaded throughout the Principles framework, and rightfully takes its place as one of the identified big ideas. Let's take another look at the view of data from a slightly different context. All through the course, we've been talking about computational thinking, and let's sort of run through that with a specific focus on data. You have some experience, whether it's real or imagined, and you abstract that experience into some sort of data representation. And then once you've done that, you can explore it. You can, if it's a single point of data, you can perform summary measures. If it's multiple points of data, you can create a schema, like a database, and then mine that schema for relationships between your variables. If you continue to grow in complexity, you can create a whole model. So now you have multiple pieces of data, and those pieces of data interact with processes in a systemic kind of way. And you can execute your model and turn it into a simulation. So all of those sorts of activities comprise the idea of data analytics, which is a subset of computer science that includes all the ideas and principles and methodologies that permit knowledge to be drawn from, guess what, data abstractions. If you are a data analyst or a data scientist, how would you spend your day? The process that we just went through a second ago, where you have an experience and you abstract that into data, that is very iterative. And in fact, it starts with what I call a Scooby-Doo moment. You know, one of those times where your little Scooby-Doo self goes, I didn't see that coming, that's weird, I wonder what. So that kicks off this iterative process where, again, you construct or choose an abstraction. You take some measurements to acquire some data values for your abstraction. You would explore your collected data set. So there's pre-game activities where you scrub your data and get it ready to be mined. And then there's counting and classifications and correlations. And from that, you have mined your cleaned data set to come up with some conclusions, but they're tentative. So you would conduct some experiments to see test how viable your conclusions are. And if you've done your experiment well and in a rich kind of way, you will come up with, some more Scooby-Doo moments, some more sorts of questions that you want to run back through this process of what a data analyst does on an ongoing basis. So with that sort of as a look at what do we mean when we talk about data in the context of the principles course, let's start talking about what exiting competencies we want our principal students to have when they have finished the course and thereby completed this data thread. So what I did to help that conversation along was to create a curriculum roadmap. And my organizing principle for that roadmap was the complexity of the abstraction. I have divided my curriculum map into single data points, multiple data points, when we get to the multiple data points, you will see that I have divided those into schemas, and then as we get more complicated, models and simulations. If you take a moment and look at the chart I provided that has this little curriculum roadmap, you will see that it's divided into columns, and the columns include competencies, capabilities, and a taxonomy. Anytime you learn some new subject matter, I think it's important to kind of identify a key set of ideas that you really do need to master so that you can have meaningful and rich conversation around the topic. So let's run through this really fast. You don't have to hang on the edge of your seat. You have access to the PowerPoint slides that go along with this. Looking at first, single point data abstractions, what kind of activities, what kind of competencies and capabilities would we want a CS principal student to have? And here I think it is important that a student knows something about normal distributions and that a normal distribution is symmetric. They should understand that there are significant deviations, if you will, standard deviations that go out, I would argue at least 3 deep, should be within their knowledge base. They should also have some sense of when you're trying to get your arms around a single data construct, it's important to take both measures of central tendency and measures of dispersion. I actually have my students calculate for measures of central tendency. We look at the median, the mean, and the mode, and then for measures of dispersion, I will have them calculate the range. But I draw the curriculum line at having my students actually calculate the standard deviation. We talk about what the idea behind the standard deviation, but it's an error-prone calculation, very tedious. If you make a mistake, it bubbles through. So I think that's a nice place in the curriculum, at least for the students that I have, to talk about it. The mastery there for me would be at the concept level only. I have marked on my curriculum roadmap other concept only as we fight for time and inclusion in the principal's curriculum. Those things that I think it is perfectly okay to just talk about at the idea level and not actually require the student to have some hands-on fluency with the idea. The taxonomy that goes along with single point data abstractions, I think, include skew. If you are trying to get your arms around a single data construct, if you don't take measures of both central tendency and dispersion, you can be misled if your data is skewed. And there's some other ideas that I think are important too. I've listed them there for you: outliers, validity, reliability, and making sure you understand when you have gathered linear data versus categorical data. Linear data would move in the function of a line, where categorical data is more like yes or no. It's not gonna grow. Moving from single point data abstractions to multiple data abstractions, I think we need to talk about several different levels. The first level is really an extension of single point data abstractions, and at this level you are doing summaries by categories. That's really all a pivot table is doing. So I think it's important for a student to be able to create a pivot table, and what that allows a student to do is to maybe bubble up some patterns, make some higher level sorts of conclusions about content in their data sets. Moving beyond classifications and summaries, we would actually explore correlations. And I think here it's important for students to know whether a correlation has a positive or negative direction, and whether it's strong or weak. An activity there would be making sure that they could interpret a scatter plot. Going even more complicated into data, I think we look at schemas. So a schema is a model of a database, and I have my students look at relational databases. I think it's important for them to understand that when you mine a data set, if you're doing anything with the stewardship of science, you need to make sure that your results can be replicated. And if you have mined a database that is not in third form normal, you have absolutely no guarantee that the data set could be maintained over time. So no one could replicate your conclusions. So we do a little take on relational databases, what it means to be third form normal, and we look to make a connection back to programming. We look at a specialized programming language of sorts called SQL, where we query a database to mine it for information. Only two levels up from this. The first is a model. So a schema is static if I allow my various data pieces, my data constructs and abstractions to live in a system with interactions, then I have created a model. And we do just a little bit of work. In fact, I play a game, as you'll see here in a minute, when I cover models. I think a student should be able to just recognize visuals of some of the more naturally important occurring models. So I think they should just be able to recognize visually whether they're looking at a linear or exponential or logarithmic. I don't think we have time, nor should we put math backbone requisite in the principal's class to have them deal mathematically with growth rates. Just recognizing the visuals, I'll be happy. If we execute a model, we can create a simulation, and there's just a world of powerful simulations in the public domain that will provide some rich educational opportunities for your students. So a simulation will allow you to advance a model forward in time and establish different sorts of constraints and see what kind of things happen. For my roadmap, in the accompanying PowerPoint slides, I have also given you a second look at this table where I stripped off the column for taxonomy and I added a concept column for activities. In subsequent videos, I'm going to walk you through my favorite 5 activities that I do in the data unit. While I have 5, you will see that 4 of them occur over and over in my curriculum map. So when I start off looking at just single points of data, I play a game called Who's in the Box, and I use little decorated clothespin, costume clothespin figures to help students start exploring the concepts of central tendency and dispersion. When I start looking at higher levels of abstraction, I play a game called Clue. At the beginning of the semester, I tell the students that I've been informed there's a spy among us, and we do logical processing of data constructs to winnow out by the end of the semester who the spy is. And I also play a zombie contagion game so that we can practice a little bit of SQL and we can move from a schema to a model to a simulation. So they move that data set forward in time, and I cheerfully will provide you with the data set I created for both Clue and Contagion, so that hopefully you can have some fun with that. To try and give you as many materials as you would like, I hope you will at least watch, let's see, you've watched the introduction video. This is the lowdown on data. I hope you will permit me a data rant where I talk about the importance of the data thread to the overall mission of the principles course. And then finally, I did a little video that highlights the activities I do in my data unit. And then for those of you who are just real gluttons for punishment, I did a drill down on separate videos describing each of my favorite data activities in glorious detail. Again, all of my materials are cheerfully provided to you. I hope the roadmap is helpful for you as you begin your journey on teaching the data thread in the principles class. And I look forward to getting these materials back, improved, and enriched.